Page 198, question number 6. By considering the graph of functions or otherwise verify that cos theta equals cos minus theta. Okay. So there are two ways we can do this. One is this. First, you need to know this identity. Cos theta is equals to minus cos 180 minus theta. First, for tan it is again same. Tan theta is equals to minus tan 180 minus theta. Only for sine it is different. There is no value, this is just the identity. I'll explain. First, compare these three identities 1, 2, 3. Cos theta equals minus cos 180 minus theta, then tan theta again negative sign, sin theta is with positive. So understand this, we need to know the quadrants. So this is 0 degrees, this is 90 degrees. In this case we move anti-clockwise. This is 180 degrees, 270 degrees, and we end at again 360 degrees when one revolution is complete. So this is known as ASTC, or you can also call it add sugar to coffee. For the first 90 degrees, whatever you try, sine, cos or tan. So sine theta, cos theta or tan theta, whatever you try, when the angle is from 0 to 90 degrees, 90 is not included, so these are always positive. So first quadrant is positive for all. Second quadrant is positive for sine only. Third quadrant is positive for tan only, and fourth quadrant is positive for cos only. For example, if I say sine of 10, whatever it will be, that will be positive. If I say cos of 10, that will be positive, and tan of 10, that will be positive. And if we cross this 90 degrees from 90 to 180, so let us say we talk about sine of 110. So it is more than 90 and less than 180. We are in this second quadrant. First quadrant, second quadrant, third quadrant, and fourth quadrant. So we are in the second quadrant, and we know that this is sine. So only sine is positive. When you punch in sine 110 in your calculator, you will get a positive answer. For cos 110, you will get a negative answer. For tan 110, you will again get a negative answer. Now understand this with the graph, only these two examples. If we sketch for sine, this is the sine curve, and you can see if I divide it into four quadrants, 1, 2, 3, 4, which is 90 each. So this was 90, this was 180, this was 270, and the last is 360. Now see, in the first quadrant from 0 to 90, sine theta is positive, right? In the second quadrant, look at this, from 90 to 180, sine theta is still positive. In the third quadrant, from 180 to 270, sine is negative, and in the fourth quadrant again, from 270 to 360, sine is negative. So sine is positive in the first two quadrants and negative in second two. What happens for cos? Do not forget to relate this with this x-axis, y-axis, okay? So sine is positive in first two and negative in second two. A is all positive. So when we sketch for cos, this is the cos curve. Again, split it into 4. So when we split it into 4, we now know that it is positive in first, negative in the second and third, and again positive in the fourth. Now come back to this thing. So A means all positive. So cos is positive, but in second cos is negative, in third cos is negative, in fourth cos is positive. Last one for tan. If we sketch the graph for tan, this is what you get. So first is positive quadrant, second is negative, third is again positive, fourth is again negative. So now look at this, first and third positive. So see, first is positive for tan and third is positive for tan. So it is just a quick method to memorize it this way. Add sugar to coffee. all positive, that means sine, cos, tan are positive. Then only sine, then only tan, then only cos. So if we come back to this question, it says cos theta is equals to cos negative theta. So if you write cos of theta and we draw this and label this as theta, the other part is cos of negative theta. So when you draw this positive theta, actually means that you are moving in anti-clockwise direction, and negative theta means you are moving in clockwise direction. So if you move this same angle in this direction, this would be that theta, or I should label it minus theta. So now look, we knew that this was add sugar to coffee. Cos theta is actually positive, and cos minus theta is also positive because it lies in the fourth quadrant, cos quadrant. So both are positive. Now the last thing, why are they equal? First thing, they are positive or negative? Yes, both of them are positive. And why are they equal? For example, if you punch in cos 10 in your calculator, you will get a positive answer. If you punch cos negative 10, you will get the positive and same answer. Now the reason why they are equal, it is known as basic angle. What basic angle is? For example, we say that we have four angles, 1, 2, 3, 4 in all four quadrants, and these all four angles are always equal when we talk about the basic angle. So for instance, I say that this is 10 degrees, so all these will be 10. Now you have to tell me the angle marked in black. If I say this is sine of 10, please tell me this second angle. What is this angle marked in blue? This angle marked in blue, is this 10 degrees? This whole thing. No. This whole thing, it always 170. It always starts from 0 and moves in anti-clockwise direction. Now this green angle, sine of 190, and the last one in red, this angle. $350. Now see, if we were given with these values 10, 170, 190, 350, we can check it in reverse order that basic angle of all these four is 10. If the basic angle is same, the value will be equal. Now if you punch in your calculator sine 10 and get me the value, I'll do it with you so we have it double checked. So I'm punching sine 10 and I'm getting a value of 0.1736. This is 0.17. So all of these will be 0.17 with only one difference, that is of positive and negative. And we know what it was, add sugar to coffee. We know sign is positive in first two and negative in last two. So these first two are positive and last two are negative. Please check. Punch this in your calculator, sine 10, sine 170, sine 190, sine 350. Because the basic angle is same. Thank you. So when the basic angle is same, the value is same, the only difference is of positive and negative. So now if we know this, I can say that sine 10 is equal to sine 170 because the basic angle is same, and I can say that it is equal to sine 190 with a small clause. Sine 190 do gives me 0.17 but with negative, so this negative multiplied with negative makes it positive and it becomes equal to sine 170 and sine 110. And the last thing is sine 350 itself, again with a negative sign for all of these four to be equal. Now, without going into detail, yes, anything. This is just the example. We can use anything. This was just the example to understand. Now, for example, the question is cos of 30. Without drawing, may I say the other would be cos of 150? Definitely, I'm sketching it in my mind. That would mean, yes. Just a second, let me write this. That's right. And the next thing would be cos of 210. So you got it by adding 30 in 180. And the last one is cos of 330. Now we have to add positive and negative signs. We know add sugar to coffee. We know that cos is positive in first and last only. So first is positive, last is positive. The values in between them are negative. If you multiply this negative value with negative sign, that will turn into a positive value. So if I write it in this way, just to compare, cos 30, cos of 150, cos of 210, cos of 330. So we know that the basic angle is same, and I'm punching cos 30 in calculator and I get square root 3 by 2. So all of these are actually square root 3 by 2. Square root 3 by 2, square root 3 by 2, but with a clause that it is positive in first and last. So first and last is positive, other two are negative. Now again, missing the details. If I ask you, is it true or false, and I tell you that, if I ask sine of 50 is equals to sine of 130, will you say it is true or false? Let's check. This is 50 first angle, and if I draw an angle of 130, yeah, so having this, no issues. So if we have the basic angles which are actually same, basic angles are same, so that means they will have a numerical value which is exactly equal. And yes, they had a basic angle of 50, and because it is sine, add sugar to coffee, it is positive in the first two, so yes, that's true. One more example. Cos of 15 is equal to cos of, let's say, 165. Is it true or false? Yes. So now it is false. Again, cos of 15 is equal to cos of 165 with this negative sign. We'll do that example. It is the same case. It just changes the quadrant and nothing else. The concept is same. So if we look at this, cos 15 and cos 165, when it is 165, the basic angle is again 15. So yes, the value would be same, and we know add sugar to coffee. First is positive, second is negative, and then this negative sign multiplies with negative value, giving it a positive answer. So now this is again true. So for tan, tangent tan of 10 is equal to tan of 170. True or false? These two do have the same basic angle, but add sugar to coffee. First is positive, and then in second, 170 lies in second quadrant, second is negative, so it should have been written in this way for it to be true. One more. Tan of 10 is equals to tan of 350 with a negative sign. Is it true or false? That's true, because both of them have this same basic angle, first thing, and because of this negative sign it turns out to be positive again. One more. Tan of 10 is equal to negative tan of 355. True or false? That is confirmed false. Although this gives you a positive answer, but the answers are different because they do not have the same basic angle. Basic angle for tan 10 is 10, basic angle for tan 55 is 5. How will you do that? 355 would end up here. So if this is 355, you are left with 5 degrees. The basic angle is always with the x-axis. It is always with the x-axis. So is this concept and this question clear? Last part, okay. In this case, we knew that tan 10 lies in first quadrant and that will be a positive value. In this case, we knew that tan 355 would lie in the fourth quadrant, and fourth quadrant add sugar to coffee. We know that tan 355 itself would be negative, but we have written a negative sign outside. So negative into negative would result in positive. Both are positive, but that was to create confusion. Both are positive, but they do not have the same value because first basic angle is 10 and the second basic angle is 5. The basic angles are different, so they'll have different values. Another example, if we say we do it with 5, so 5, 5, 5 again, last one again 5. First angle would be 5, second angle would be 175, third angle would be 185, the last fourth angle would be 355. So all these are having same basic angle, that is 5. So whatever we do, sin cos tan, let's do with tan, 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 tan and tan, they all will have this same value, tan of 5, tan 175, tan 185. So tan of 5 is 0.087. So this is 0.087. All of these will have a numerical value of 0.087 because the basic angle is same. That's why they are having the same value. But we know that add sugar to coffee, we know that first and third will be positive. So first is positive, third is positive, and remaining two are negative. Values are equal. We need to check two things always. First, is the basic angle same? Second, is the positive negative sign same? For them to be equal or to be equated. Clear? Okay, now let's have a look at this question. Good one, Mohammed. Okay, cos theta is equals to cos of negative theta. Now you know that cos theta was here and cos of negative theta was here. When the angles are actually same, this negative sign only indicates the clockwise direction. We know that the angles are same, the basic angles are same, the value must be same. And add sugar to coffee, both are positive. Yes, this is true by considering the graph of function or otherwise. This is the otherwise method, or the graph of function would have been this, sketching a cos curve and in negative direction as well. So in positive direction, let me consider the value of theta is here, right here. So negative theta would be this, and we do have the same value and same sign. okay, from graph or otherwise. This method is easy, like sketching the quadrants. Now look at the second thing for sine of theta and sine of negative theta. First we need to sketch the angles. If we draw this Cartesian plane, this is theta, then for negative theta it should lie on this space. First thing first, sine theta, first quadrant positive. We know that the basic angles are same, the value is positive for first one. For second one, add sugar to coffee, add sugar to coffee. We know that sine theta in the fourth quadrant would be negative, so this thing inside the box is negative. When you multiply this negative thing with negative, it results in positive again. So left hand side positive, right hand side positive. Yes, it is true. Last thing, sine theta minus 90 and minus cos theta. Now this is the yes. In this question there is no shift. Compared to sine graph, yes. Okay, now you need to know that whatever cos theta is, it is always equals to sine 90 minus theta. That is simple identity. For example, cos of 10 is equals to sine of 80. Let me show you. This was something we did in O levels. For example, you have this right angled triangle and we name it A, B and C, and then we mark them with 3, 4 and 5 centimeters all. So if I write cos of A, so cos of A is base over hypotenuse, that is 4 by 5. Now see cos of A, and if I write sine of B, sine of B is perpendicular over hypotenuse, again 4 by 5. You see cos A and sine B, they are equal. So if I write cos of theta, that is equals to sine of 90 minus theta. When we apply this identity, it actually switches it from A to B. For example, if I say this is 10, this would be 80. If I say this is 20, then this would be 70, because some of these two are always 90. This 90 is fixed, some of the remaining two is always 90. So the simple identity. Moving on to the question. Now it says sine theta minus 90. So sine theta minus 90, let me just get some space. So sine theta minus 90 could be written as cos theta, and on the other side it was negative theta. So negative sign. Why negative sign? Because the true identity was 90 minus theta. This is theta minus 90 in the question. I've written the identity. I should have copied the question. First clear this confusion. This was theta minus 90. I've written the identity. Okay, so let me just replace it. So the question is sine theta minus 90 is equals to minus cos of theta. Compare this with this sketch. If this is theta and I subtract theta minus 90, whatever angle I get, that would be of negative sign. So sine of, or you can write negative cos theta. So that is simple identity. Is this thing clear? Sine 90 minus theta was cos theta. So sine theta minus 90 would be negative cos theta. This is the identity. We will be doing these identities in detail in this chapter, trigonometric identities and equations. Any more questions? Sketching part or the transformation part. Describe geometrically the transformations which map graph of y equals tan x onto tan 1 by 2x. This is the value of b, right? If I write tan bx, a tan bx plus c. Remember this? We did this in the last class. What was b supposed to? Sin bx plus c. What was the role of this b? If it is 3, that means we get to see 3 cycles in 360. If it is 4, we get to see 4 cycles in 360. So if it is half, we get to see half cycle in 360. For example, sine of half x or half theta, we will get to see half cycle in 360. That means this is 360 and this is 720. So coming back to the question, tan x onto tan half of x. So the original graph of tan x means that in 360 we get to see 1 cycle, and the second tan half of x means in 360 we get to see half cycle, and in 720 we get to see a complete cycle. So this would look like this. Tan half x will look like this, and tan of x will give you one complete graph in 360. So this is the difference. So now what is actually happening? May I say that moving from tan x to tan half x, the graph has stretched horizontally with a scale factor of 2. Would you agree? Let me sketch sine. It is always easier and simpler to understand. The concept is 100% the same. If I draw sine here and mark it 360, then I draw one new curve, double the size, and mark this 720. I've already sketched it. Let me say this is 2, this is minus 2, this is 2, this is minus 2. Just by looking at it, by the shape, we can say this is sine. It is completing in minus 2, thank you, minus 2. So looking at the first shape, we know this shape is for sine, and it is completing in 360, so we know it is only x. And the amplitude is 2 and minus 2, so this is the equation. Just by looking at the graph, we can tell the equation. If the examiner gives us the equation, we can sketch. If the examiner gives us the sketch, we can tell him the equation. Now look at the second graph. Amplitude is still 2, so I write 2. Shape is still sine, we write sine. But I'm getting to see half of the cycle in 360, so I choose to write 1 by 2 here. Now we compare it with the third one. To understand transformation part, so 1, 2, and this is 360. This is 2, this is minus 2. First thing, shape is sine, yes. We get to see 2 cycles in 360, so we write 2x. Amplitude is 2, so we write 2. Now if we say the first graph is the basic one, if we compare it with the first one, making it the standard or basic, from this to this, we say it is a, please excuse my spellings, it is a stretch with scale factor 2 in horizontally, or we could say it is a sketch of scale factor 2 along x-axis. And if we compare these two, I can say we always call it a stretch, we don't say it a compression. It is a stretch with scale factor 1/2. If I send you to get a photocopy, this is the page, and I tell you, explaining that part, if I tell you to get the photocopy of this page and I give you that the scale factor is 1, the copy you will bring would be of equal size. And if I send you and I tell you to get a copy and the scale factor is 2, so definitely it would be double the size of original, right? And if I tell you to get a copy and the scale factor is 1/2, so that would be half the size of original copy, right? Same, double, half. So I'm telling you that get an enlargement of scale factor 1, that means it is not enlarged. Then I'm telling you that get an enlargement of scale factor 2, that is enlarged by a factor of 2, it is doubled in size. And then I again tell you get an enlargement, I'm still saying enlargement of 1/2. So enlargement of 1/2 actually means half of it. You always explain the terms using some standards. So the word is stretch. If I tell you that after 365 days you will stretch vertically by a factor of 1.003. So whatever your height is, you can multiply it with it, and you'll know that after 1 year you will be this much longer. So definitely in case of humans, you're not getting shrinked. So is this part clear, that we call it stretch? So scale factor more than 1 means it is spreading horizontally. Scale factor less than 1 means it is squeezing. We just use the word stretch. And same is the case with y-axis. Now if I quickly sketch a graph of sine theta, it looks like this, completes in 360, this is 1, this is -1. New graph for comparison to sine theta, this still completes in 360 but with a vertical stretch of 2 and -2. So what can we say? We can say it is a stretch of scale factor 2 along y-axis or vertically. Getting it? Same graph completes in 360, so I'm very sure it is sine theta, but I'm not sure what the amplitude is because the information is missing. So if I write 1/4 and -1/4 here, so now I know I can write 1/4 here, right? This is still sine. Now we know it is compressed, but I'll say it is a stretch of scale factor 1/4. Looking at the number less than 1, we understand that it is reducing in size. 1/4 along y-axis. So these are the questions you'll get in transformation. Now we've shifted it with x alone, with y alone. Now let's disturb it in both ways. So let's say the original graph was sine theta, ending at 360, lying between 1 and -1, and the new graph is 2 sine 2 theta, or just to make the difference between these two, 3 sine 2 theta. So when we discuss, we know actually what we are talking about. So the shape still stays the same. We know the graph lies between positive 3 and minus 3. 2 theta would mean we get to see two curves in 360. That means one curve in 180. Any doubts? Now let me say the curve A is the original curve and curve B is the transformed curve. So the examiner tells you to explain the transformation. Before we write something, we know it has stretched in positive and it has been compressed horizontally. Do you agree? So now you just have to use your words. It is a stretch with scale factor. What do I write? I'm going for y direction. Scale factor, what do I write? Scale factor 3. Yes, along y-axis. Second part, and a stretch of scale factor along x-axis. What should it be? 1/2. So never confuse it with this. This is 2 and you know it is being compressed, so you wrote 1/2. This was 3 and this is still 3. Clear? Now this was simple vertical and horizontal stretch. What if you do not stretch, you just move it? First is sine theta. We don't always have to sketch it. We can do it without sketching. So this is the first A. From A to B, this is sine theta plus 1. How will you answer this? Sine theta plus 1. Yes, and what is the word we use? Translation. This was sine theta and the new graph is raising the complete graph by 1 unit. So it has moved the complete graph by 1 unit. So we say it is a translation of, in x direction there is no movement, in y direction there is a movement of 0 1. Translation vector is 0 1. So if we say sine theta, original graph again, and new graph is sine theta minus 2. So this will move this complete graph 2 units downwards. So it is a translation. You remember transformation chapter of O levels? So it is a translation with translation vector. We know there is no movement in x direction, 0, and it has moved down with 2 units. So it is a translation vector 0 minus 2. So this was the vertical shift. Now the horizontal shift, we are doing this without squeezing it. We are not changing the value with theta or x. For example, you have sine of x. So sine x will look like this, ending at 360, lying between 1 and minus 1. And then we do sine of x minus 30. Minus means it is moving towards right. So moving it towards right, 30 means this lies between 1 and minus 1, and 30 means it starts at 30. Minus 30 means it has moved right. So this was 180. 180 plus 30 is 210. 360 plus 30 is 390. So for this we can say it is a translation. Anyone would wish to complete the sentence? Of So it is a translation vector. It is moving towards right. So this is 30, 0. And yes, there are few limitations. The examiner do not combine all these transformations in one question. So now let us combine these two. If I say the first one was sine theta, this is sine theta, ending at 360, lying between 1 and -1, and the new one is this. Let me say it appears like this. I'll fill in the values, but can you just guess the transformation? Yes, whatever the angle will be, it is moving in horizontal and vertical direction both. So looking at the y-axis, can you guess what the value of vertical translation is? 1. This was at 0. Now this value is at 1. Okay. So you set it 45. So let it be 45. 360 plus 45 is 405. So it starts at 45. It ends at 405. So this is the graph of sine theta minus 45. This negative is moving it towards right hand side, and plus 1. So we can still say it is a translation because it is moving to right and upwards. So it is a translation of translation vector what will it be? Translation vector. In x direction it is 45 and in y direction it is 1. 45 degrees x and 1 units upwards. Yes. They can do that. Okay, one thing. Yes, one thing. You yourself are telling it a translation. So it is always from sine to sine, not from sine to cos. The translation is from sine to sine or cos to cos or tan to tan. So we'll always have to guess the values. Like earlier you were saying that sine and cos are actually 90 degrees shift. So if I just shift this y-axis 90 degrees to right and erase the previous graph, so I won't be able to tell that it was sine or cos if I complete this cycle, because now it is starting from this point. Let me override it with the red color. So having this much information, yes, we won't be able to tell it is sine or cos. But if it is labeled, suppose this is 0 here, we know sine graph starts from 0. If you label 0 on the next stage, we know that cos graph starts from 1. So whenever you are given with sufficient information, you will always be able to identify. If the information is missing, the question would be easy. And in case of translations, in case of transformation, it is from sine to sine, cos to cos, and tan to tan. In case of tan, there will be nothing as of vertical stretch because the amplitude is not an issue for tan. Okay, let's have a look at this. Look at this D part. The graph of y is equal to sine x minus 10 onto graph of sine x plus 10. So x minus 10. Minus means it is already on positive 10 units and plus 10 means it is on negative 10 side. So from moving from this graph to this means we are moving 20 units to left. Any confusion? 20 units to left. Like we'll be telling that it is a translation of minus 20 is 0 for this last part. Look at C part, that's one interesting one. Cos to minus cos. So this was cos, and for minus cos, when you multiply it with negative, positive becomes negative, negative becomes positive, and this is it. So this is minus cos. Definitely that's a reflection. So what is the transformation? It is a reflection in x-axis. Clear? And now look at this question number 14. It is just related to the questions you asked earlier, that it is sine or cos. So if we don't look at this statement, we just look at the graph. So we may get confused that it is shifted graph of sine or cos, but when we look at the values in detail, this is 120. If it was not shifted, this should have been 180. So 180 to 120, that is a difference of 60. That means it is shifted towards left hand side for 60 units. And if I consider this shifted graph, so this point should have been here before the shift. So now we can pretty much assume that it is a sine graph. So if you are given with sufficient data, it is very easy to guess. If the data is missing, question would be related to that and nothing difficult. Getting comfortable with transformations? Okay, now a quick look. This starts from 0, crosses 180, ends at 360, a perfect sine graph. Yes, it is sine theta. What is this alpha telling? The question is saying something here. So when you subtract, it moves to right. When you add, it moves to left. And at the end, the same dialogue. You must have memorized it. Practice. Yes, do ask, please. Whenever this is the case, such information would be given. We cannot tell. You're talking about the same graph, right? You're talking about this graph. Okay, 30 degrees right. If we assume that it has moved 30 degrees right, then yes, it could be a cos graph. Let's check. If it has moved 30 degrees right, this value should have been 90. Subtracting 90 from it, and this should have been 0. Yes, we can say. So sufficient information must be given. And if it is the case that sufficient information not given, they will never ask you if it is cos or sine. A sine bx plus c. So there must be information to fill in these values A, B, C. A cos bx plus c. There must be something to fill in these values. And as we know that sine of x is equals to cos of 90 minus x. If I can relate the topic, have you studied waves in physics yet? So, okay, I won't confuse you. I'm just talking about the topic which will overlap. So, do you know what in phase particles are? Okay, so have you studied superposition of waves? Okay, so yeah, exactly that point. So now if we have these two waves, blue wave moving towards right and the red wave moving towards left. Let me change this. This is causing confusion. So if we add these values, this always results in 0. If this is plus 1, this is minus 1. If this is plus 0.7, this is minus 0.7. In this case, we can say that these two waves are 180 degree out of shift, out of phase. They are 180 degrees out of phase. If they would have been in phase, this blue and this red, this 1 would result in plus 2, this minus 1 would result in minus 2, and 0 stays at 0. Agree? So we can say that it is out of phase, 180 out of phase. So yes, we can say sine theta and cos theta are 90 degrees out of phase. So sufficient information must be given. Okay. Any more questions? Okay. Thank you so much. Inshallah, we will continue with chapter 10 tomorrow.